All right, these are answers to page 620 here, and we're trying to use the integral test for this. So on the integral test, what we'll do is we integrate this expression as if it was a function from here to here. Okay, so that means we're going to take the limit as b approaches infinity of the integral of this. So if we integrate, that's going to be natural log of 3x plus 5. But if you were to take the derivative of that, the derivative would be 1 over that times 3. We don't want that 3 there, so we're going to be dividing by 3. And we have this 2 that's sitting there, so it's going to be like that. Now you could do a u sub if you want, or you can kind of work backwards, but that's what the integral of this expression is, 2/3 natural log 3x plus 5. Okay, we're going to do that from 1 to infinity. From 1 to b. All right, which gives us 2/3 natural log of 3b plus 5 minus the 2/3 natural log of 8. Now, the natural log of 8 obviously is okay, but we're taking the limit of this as b goes to infinity. So if this goes to infinity, the natural log of it will go to infinity, so therefore this diverges. The integral itself will diverge because this is going to go off to infinity. So if the integral diverges, then so does the series. Number 6, if I rewrite that, this is 1 over 2n plus 1. And that's what each of these terms really is. And so therefore I'm going to integrate from 1 to infinity 1 over 2x plus 1. Okay, which is going to be the limit as b goes to infinity of natural log 1/2 natural log 2x plus 1 from 1 to b, and that's going to be 1/2 natural log of 2b plus 1 minus 1/2 natural log 3, and we're taking the limit as b goes to infinity. Same reasoning as 2, this is going to diverge because the natural log of 2b plus 1 will continually get bigger and bigger and bigger as b gets bigger and bigger and bigger. So we have kind of a divergence there. All right, 27. We're going to take the integral again from 1 to b, the limit as b goes to infinity of 2x over x squared plus 1 dx. Okay, and now again, I can see that the derivative of this is right there, so this will become a natural log problem again. It's the limit as b goes to infinity of the natural log of x squared plus 1 from 1 to b, which will then be the limit as b goes to infinity of natural log of b squared plus 1 minus natural log of 2. As b gets bigger and bigger, so will the natural log of this. So again, this diverges. So all three of these diverged by integral test here. Okay. We get to 27, and now if I do this as an integral test, I get from 1 to infinity 1 over square root of x dx, which is going to be the limit as b approaches infinity of the integral of this. Now if I rewrite that as x to the negative 1/2, I'm going to get x to the 1/2 over 1/2, or 2 square root of x, okay, from 1 to b. And so this is the limit as b goes to infinity of 2 square root of b minus 2, and that diverges. All right, so now the rest of these just want us to make a decision. I mean, we've already looked at the integral test. We now can prove why a p-series converges or diverges from the integral test. So what we want to do is just kind of look at this in a rewritten form. This is 1 over n to the 1/5. The rule is if p is less than or equal to 1, then your series is going to diverge. So this diverges, p is less than or equal to 1. You may even want to say, you know, what p is. But that's the reason. Okay. Over here, our p-value is 5/3, and so this one will converge. This converges. P equals 5/3, which is greater than 1. So if p is greater than 1, convergence. This here, if we were to write it, is 1 over square root of n, which is 1 over n to the 1/2. So this diverges. P P equals 1/2, which is less than or equal to 1. For 32, if I rewrite this is 1 over n squared. P equals 2, which is greater than 1, so this converges. For 33, this one's a little sneaky. This is 1 over n times square root of n, which is 1 over n to the 3/2. N to the first, n to the 1/2, put it together, you get 3/2. So this converges. P equals 3/2, which is greater than 1. For 34, if you look at this one, this is 1 over the cube root of n squared. So this is 1 over n to the 2/3. So this diverges. P is 2/3, which is less than or equal to 1. 35, this converges. P is equal to 1.04, which is greater than 1. And then finally on 36 here, we have n to the pi. This converges. P equals pi, which is greater than 1. So in those P series, you can write it as 1 over n to a power, then you just look at the power and see if it's bigger than 1 or less than 1.